Okay, so that's well and good. Now, I guess a question would be, can we use these rulers, or what I've drawn as these rulers, to figure out an object's absolute velocity? Well, let's just take a look. Okay, so we have two rulers, and these represent the point of view of two different observers on the same ship, or two separate ships. So we have A and B. So A is right there at this 2, and B is the one at this 2. They're in the center because, again, when they move, the entire universe contracts to them as a center point. So let's just take a look at that. Okay, so they're going to measure their distance to something here, like a fictional, to an object here. We're going to say it could be a rock or some sort, or another ship. Okay, that ship could be moving or stationary. We don't really care. Now, they're going to but what is going to matter is that they're going to need to take their measurements at the exact same time. And they can do that because, again, they're under the same, they're at the same velocity, so they can have the same dilated time, so they don't have to worry about time dilation with each other, because if they did, then it'd be very hard for them to measure, what light they are at the same time. Okay, so this is 0 to 2, and this would be 0 to 3. Remember, this is 2 plus a 1, right? Because there's still a gap of 1 here. It's just, again, my ruler here doesn't extend that far. So let's just figure out how we can do that. Well, first of all, we know is L prime equals L times this coefficient. Now, let's suppose we're at 0.6c. It actually doesn't really matter what distance we are, but let's just say, suppose we are at 0.6c. We're going to use this number because we used this number before, and it kind of gives us nice round numbers to work with. Okay, so we can have two different equations because we have A and B as observer. Okay, so, and we also know B equals A plus L because, again, this will be L, this one distance here. And it's just a matter of merging these things around, and we get the same equation back again. And if you plug, and again, we're going to figure out what distance we are here, right? So 2 to 0 here. When we contract that length becomes a 1.6. And if we contract this length of 3, contracting down to get this length, we get a length of 2.4. Putting everything into the equation, and we get 0.6 C if we put that in. Again, it's actually, you can do this in your head. It's pretty straightforward because, again, this subtract that is 0.8. We square that. 0.64. L is 1. So 1 subtract 0.64. 0.36 square rooted equals 0.6 multiplied by C. So that would be our velocity. I think one very obvious question is, if we are an stationary observer and we're seeing these two ships, we will see them contracting length as well. So, they're almost mirroring each other. Because obviously imagine these are two spaceships that are moving, then yeah, they will contract in length to us if we're stationary. Again, we're technically not stationary because the Earth is obviously moving. So could a stationary observer, or alternatively a third observer, use this kind of formula to measure the absolute velocity of two moving objects, provided that these objects are moving at the exact same speed? And the answer is no. And here's why. The reason for that is that, yes, we would see two objects, and we would see them already contracting length. The issue here is that we don't know the original contraction of that length. And again, we don't know the absolute velocity either, right? We only know the relative velocity relative to us. We don't know their absolute original length. Now, the reason why we can do it when we are the moving ships is because we don't need to know the original length of an object. Because we have a third object to measure ourselves to, right? Because remember, we're measuring, when we're on these two ships, or again, this one ship with two observers, we are measuring the length, the distance to another object. Now, because it's the distance to another object, we can use those distances measured to plug into this formula. If we're watching two moving ships, or again, one stationary ship, or one moving ship, we don't have that measurement point to get this calculation.